Hello everyone, welcome to Coders Camp, and we are at the 21st day of April LeetCode challenge, and the problem we are going to cover today is triangle. So the input given here is a list of lists which consists of integers which represent our values in triangle. So now we have to return the minimum path sum from top to bottom. So let's understand this problem with an example. So here is our given list of list represented in the form of triangle because our first list size is 1 and second list size is 2, so on and goes till the last list size is 4. So now if you represent these numbers in this form, it represents a triangle. It also makes us remember a different problem which is Pascal's triangle. So now our job is to find the minimum path starting from the starting of the triangle till the ending of the triangle, and you can represent this in form of a tree as well. So if suppose my root node is 2 and the next node is going to be 3 and 4, so now we are going to start at the root node which is 2, which has to be considered as that is the only node in the top layer. So moving on to a next layer, our intuition would be choosing the minimum element. So out of 3 and 4 we'd be choosing 3 and proceed further with the minimum element to the next layer. So the minimum element is going to be 5 in the next layer. Though this is true in this case, it can always not be the actual solution we needed, because if we are choosing 3 and going for 5, this is one path. If we are choosing 4 and the next layer having the value 0, then in that case if we are choosing the next minimum element in this layer, we're going to skip this path. But actually this is the minimum path sum, so we cannot decide by choosing the minimum element and moving forward to the next layer, as the values or path can change at any point. So we need to explore both children in this side and this side as well, and further explore all the paths from that step and arrive at our solution. So one more thing we need to note here is you can either use I or I plus 1. Suppose if we are starting at 2, the possible route we can go here is adding with 3 and 4. And if suppose we are picking 3, then the possible way we can go is with 6 and 5. We cannot go to 7 as this exceed I plus 1. And from 4, you can either go to 5 or 7, but you cannot go to 6. Same way, if you draw from 6, you can move to 4 and 1. From 5, you can move to 1 and 8. And from 7, you can move to 8 and 3. So by observing this, the thing we can find is if it is a leftmost element or rightmost element, the option it has is adding with its previous index. That is, if it is 3 is the leftmost element and the only option it can add in the previous layer is 2. Same way, 6 is the leftmost element, so the only option it has is adding with 3. And similar way, 4 has only option adding with 6. Same way in the right side, 4 has the only option adding with 2, and 7 with 4, and 3 with 7. But the middle elements, that is either not leftmost or rightmost element, have two options. That is, 5 can be added with 3 or 4. Same way, 1 can arrive from the path 5 or 6. And similarly, 8 can arrive from 5 or 7. So considering all these terms, we are going to arrive at a solution. So let's see how we're going to approach this. So here we are going to use the same triangle to update the sums so far in that layer, which is minimum, and proceed till we reach the last layer and arrive at our solution, whichever minimum in the last layer. So let's start with our topmost layer, which is 2. So we are going to start with 2. We have no option, so 2 is going to be at the top layer. Moving on to the next layer, 3 and 4 both have access from 2. That is, both can include in the path from 2. So we are going to add 2 to both the cells. So once you add 2, the values are going to become 5 and 6. So now moving on to the third layer, here comes the actual problem. So in previous layer, that is 3 and 4, the index are going to be 0 and 1. So now in next layer, the indexes are going to be 0, 1 and 2. So now from the 0th index, that is from value 3, you have access to both 0 as well as 1 index, because we need to have the path from adjacent cells in the next row, that is I and I plus 1. So now from 3 you can add both 6 as well as 5. Same way from 4 you can add 5 and 7, because as the 4's index is 1 and it can consider following the path at index 1 and 2. So now let us leave 5 alone and update the leftmost and rightmost cells, as they have the only option is to add with its previous value. So now we are updating the value at 6. So far the value in previous layer is 5. So with 5 we are going to add 6, then the value becomes 11. The same way, so far the value in the previous layer is 6. So with 6 we are going to add 7. So then the value is going to become 13. Now it's time to update the middle cell where the value is 5 and it has an option can come from the previous layer either from 3 or 4. So we are going to consider the minimum path here because that is what we needed. So we are going to add 5 with both 5 as well as 6 in the previous layer and arrive at the minimum solution. So if you add 5 with 5 it is going to be 10 and 5 with 6 it is going to be 11. So 10 is the minimum path of 2. So we are going to update 10 here. So now moving on to the next layer. So from the next layer, the first leftmost element is 4 and the rightmost element is 3. So since they have only one option, let us update it directly. So the previous layer's value was 11. So adding 4 with 11 will give you 15. Same way, adding 13 with 3 will give you 16. So we have updated both the values. Now the task is to update the middle layer's value. So if you consider the value at index 1, the previous path can add up with index 0 as well as index 1. So we are going to consider adding both the values with the previous sum and update with the minimum value. So now we are going to add 1 with the previous layer sum 11 and 10. So if you add 1 with 10, it is going to be the minimum value, which is 11. I'm going to update here. And moving on to the next number 8, you can either add it with 5 or 7 in the previous layer. So the sum so far in the place of 5 is 10 and the sum so far in the place of 7 is 13. So if you add 8 with both, 18 is going to be the minimum value. So I'm updating 18. So we have updated the last layer. So we have to choose the minimum of these four values in the last layer, which is going to be the minimum path sum so far. So here 11 is going to be the minimum out of all four. So that is going to be the least path sum from the top to the bottom layer, which follows the path 2, 3, 3 to 5 and 5 to 1. So hope you're understanding this solution. So this is going to take big go of n square time complexity and constant space, as we are going to update in the same list we have got as our input. So let's go to code now. So yes, we are going to have two loops to iterate through the triangle list. Let us consider accessing this list as rows and columns. So here we have two loops. I represent the row and J represent the column, and the size of the column is going to change as per the rows. So the row size is actually the number of elements present in the column. So we are here checking if the value is not the leftmost or rightmost element, then it should be having the two options, that is minimum of its previous column and the current column. So here we are updating the calculated value in the same given triangle list. So finally return the minimum element in the last layer. So yes, let's run and try. Yes, let's submit. So yes, the solution is accepted and it runs in 4 milliseconds. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.